all, my name is Abdul Rahman and welcome back to my YouTube channel, and in this video we are going to talk about the characteristics of an algorithm. We are also going to talk about the prior analysis and posterior testing, and we are also going to talk about the characteristics of an algorithm, right? If you remember in the last video guys, I have created the video of introduction to algorithms which was the starting of this series, right? And there I have talked a lot about algorithms, like types of algorithms, what are they, how they work. So I have just referenced them, right? Now in this video I am going to talk about the characteristics, difference between algorithms and the programs, and I am also going to talk about the prior and posterior testing and analysis in this video. So first of all, let's talk about what is an algorithm. So we all of us know what is an algorithm, right? Algorithm is a step-by-step procedure for solving a problem or doing a specific task, right? It's not a like language or it's a subject, right? Like Python, Java, or like that, right? It's a step-by-step procedure for solving a problem. Now what are the programs, right? So I'm going to explain these two things with an example. So these are the algorithms, algos, and then these are the programs. Now here, what is an algorithm? Algorithm is a step-by-step procedure for solving a specific problem, right? So let's say that you are constructing a building. Now there, before constructing, you design that building, right? It's not like you go there and search for a land and then start the construction of that building, and then if you don't like the design, then you will fall on that building and then reconstruct it, right? So it's going to waste a lot of money. So you are not going to do that. So first of all, you are going to design that. Now in the programming also, there you have to design that program. Now in the programming, it's not going to waste our money, right? We can write that program, and if we don't like the design, then we can delete all of that stuff and we can rewrite that. But right now we don't have a lot of time for that, right? Now that's why we use here the algorithm. So this is the difference between algorithm and the programs. Now algorithms are called, let's say that algorithms are designed. So now in the programs, what we do is, in the programs we implement that, right? Implement that with a programming language, whether it is C++, C hash, or if it is Python or whatever it is. But in the algorithms only, we do the same thing, but we will do that in another language, and that is our natural language, like English, Hindi, or the whatever the language that we use here. So we write the step-by-step procedure how to design that program, and then we are going to implement that with a programming language, whether it's Python, Java, JavaScript, C++, C hash, whatever it is. So we are going to do that. Now this is the difference between algorithms and the programs. Now let's talk about the characteristics of an algorithm. Now first of all, let's talk about what are characteristics. Okay, so these are the characteristics of an algorithm. But so let's talk about the meaning of the characteristics. So let's say that you are playing a sports game, and that is cricket. Okay, now while playing that, you have to follow some rules, like in a team there should be around 11 members, and the ball should come in a way, and if the ball come in another way, then you are going to be out, and all the stuff will be there. So you have to follow those rules. So in algorithm also, there you have to follow some of the rules. So these are the rules, some rules that I am going to show you, but there are many more, but I am just going to show you this one. So the first one is input and output. So this is basically slash. So here I wanted to divide this, like the first one is input and the second is output, but I have written like this. Now let's say that you got a problem, okay, and that is, let's say 12 plus 2. So you will solve that problem, and then the output is going to be the 14. Now if I don't give you the question, will you able to give me the output? No, right? So in an algorithm, so there is one rule, and that is you have to give the input, then the algorithm is going to give us the output. So that is the first one. Now the second is well defined. Now what is well defined? Well defined, this is also an characteristic. So an algorithm should be clear and unambiguous, with a specific set of instructions that can be followed by a computer or other machine. Okay, so we have to set the specific instructions. Okay, let's say that you are doing something and you have to follow the instruction. Now you are following the instructions. let's say you are following the traffic rules, traffic instructions. Now while following that, you are not going to follow by yourself, right? So you are going to follow that by the rules, you're going to follow that by the rules of the police, right? You are going to do that. So like that also, well defined means an algorithm should be clear and unambiguous, and it should have a specific set of instructions that can be followed by us, and that can be followed by a computer. This is the well defined. Now what is effectiveness? An algorithm should be able to produce the correct output for any valid input. Now while giving the valid input, now let's say that we gave something like 12 is equal to 0, and then 12 is equal to 0 and multiply into whatever some wrong valid input we have given, invalid input we have given. Okay, now it's not going to print the valid output, right? So they are going to show us the error. So the algorithm, so the input should be the valid, and then the algorithm is going to produce the correct output for any valid input in a reasonable amount of time. So it should not take, let's say that I have given you a problem and it is 10 plus 2, and you are going to tell that 10 plus 2 is 12. Okay, now you are not going to take that less than 10 seconds. Now if you are taking around 1 hour, then that's not the reasonable time, right? So for that algorithm also, right, so it should have a reasonable amount of time it should take. Now let's talk about finite. Now what is finite in an algorithm? What is this rule? An algorithm should have a finite number of steps, meaning that will terminate after a certain number of steps and not run indefinitely, right? Infinitely, right? Let's say that, okay, so you are going to write numbers continuously, but you are not going to stop there, so that is infinite. Now finite means you are going to do a lot of stuff and then you are going to stop at a point, that is known as finite. Now let's say that, so the SQL server, let's take the example of a SQL server. So the SQL server is going to continuously running, it's not going to be stopped until we stop them, or if we return the program that it should be stopped at a point, then it's going to stop. If you not written a program for that, then the SQL server is going to be the continuously running, infinitely running, right? So this is the example of the infinite. So the algorithm should be finite, it should be stopped at a point. Now let's talk about the prior analysis and posterior testing in an algorithm. Now what are prior analysis and posterior testing in the algorithms, right? Prior analysis and posterior testing are the two methods used to evaluate the performance of an algorithm. Okay, so prior analysis refers to the analysis of an algorithm before it is implemented to run. This type of analysis can be used to determine the time and the space complexity of an algorithm, like how much time it's taking to solve a problem, okay, as well as to identify any potential issues or limitations. The time and the space complexity of an algorithm can be determined by analyzing the number of operations required to solve a problem of a certain size. Now let's talk about what is posterior analysis, posterior testing. Posterior testing, also known as experimental evaluation, refers to the testing of an algorithm after it has been implemented. This type of testing involves running the algorithm on a set of inputs and measuring its performance in the terms of factors such as time, space, and accuracy. So from the time, so for prior analysis is used for the time, for determining this space and the time complexity, but this is also used for time complexity, space complexity, and the accuracy. Now the results of a posterior testing can be used to compare the performance of different algorithms and to identify any issues or limitations that were not identified during the prior analysis. So guys, these are the prior analysis and posterior analysis. So anyway guys, that's all for this video. I hope you liked this video and enjoyed watching this video, and don't forget to like, share and subscribe, and I will see you in another tutorial. Thanks for watching. Thank you. Bye bye.